Hey guys, welcome back to the channel. So in this video we are going to further study about environmental biotechnology. So we previously studied about food chain, and in this video we'll start off with food web. So let's just get started with this. So food web, as you can see on the screen, is very similar to a food chain. So food chain or food web is nothing but a collection of different food chains. So let's just go through the definitions that has been provided on your screen. So several food chains interact to form a network. Energy is transferred from one trophic to another trophic level. Alright, so natural interconnections of food chains, and one organism obtained food from various other trophic level organisms. Alright, so different levels of food chains interact with each other to feed themselves. So moving on with this. So talking about the next term that we have under the subject is biomagnification. So biomagnification is nothing but accumulation of increasing concentrated toxic heavy substances such as mercury, pesticides, DDT in an organism with increasing trophic level in a food chain. So definitely biomagnification is something that is very harmful or deleterious for marine or surface organisms. Alright, so increase in biomagnification leads to death of these organisms, and as you can see on the screen. So increase in the level of mercury, pesticides and DDT are deadly for these organisms or for anyone. On with this. So talking about the ecological pyramid. So after biomagnification, which was just accumulation of harmful substances such as mercury, DDT or any other pesticides. So let's just talk about ecological pyramid. So it's basically a graphic representation of biomass and energy of the successive trophic level of an ecosystem, represented by a pyramid called ecological pyramid. Biomass and energy, which is trapped by the solar energy, gradually decrease from producer to the consumer level. So this I have already covered, as energy level decreases and only about 10% of energy is transferred, while 90% of energy gets wasted due to heat transfer or due to growth or due to reproduction. So it is estimated that 80 to 90% of energy is lost when it is transferred from one trophic level to another. So only about 10 to 15% of energy gets transferred. So there are three types of pyramids. As you can see, there are number pyramids, we have energy pyramids, and then we have biomass pyramids. Then we have two more things, that is the standing crop. So standing crop is the biomass of living material at each trophic level in a certain area at a particular time. Definitely it's the biomass of a living material at each trophic level in a certain area at a particular time, and it is measured as the mass of living organisms or the number in a unit area. Alright, so definitely these the definition of standing crop, and it is measured as the mass of living organisms or the number in a unit area. Alright, so this is very easy. So standing crop is just the amount of population present in that particular area, and we can count by counting them in a particular area of meter square. So let's just talk about some of the pyramids that we just went through. So talking about these three pyramids that we have here, first is the energy pyramid, then we have the biomass pyramid, then we have the number pyramid. So the energy pyramid is this thing, as you can see. So it all starts from primary producers, alright, moves to the primary consumers, secondary consumers, thirdary consumers, and then moves to the decomposers. So as you can see, the energy is lost and only 10% of energy gets converted. Alright, so the available energy decreases as we have the arrow here pointing this side. Alright, and the energy is lost within the transfer. This is the energy pyramid. So let's just talk about the biomass pyramid. So it all starts from the root base, which is the primary producers in every case, whether it be any pyramid. So we have the primary consumers, then we have the secondary consumers, then we have the decomposers. Alright, definitely at the top we have the decomposers, which can be yeast, bacteria, or any sort of marine organisms. So definitely the biomass available biomass decreases as we move to higher trophic levels. Alright, and it is the same with the number of pyramids as well. So number of pyramids starts with primary producers, moving to consumers, and moving on from there on we have primary, secondary and tertiary consumers. Definitely the population size decreases, the plants are many lots in number, whereas we have less amount of primary consumers, and we have even less amount of secondary consumers, and very less amount of tertiary consumers, and very less amount of decomposers as well. So these were three types of pyramids, such as energy, biomass, and number pyramid. So more this, let's talk about habitat. So the habitat is something which is a place or area where an organism lives or survives. Alright, so the place and area occupied by the entire community that includes the sum total of atmosphere and soil factors. So basically it's the sum total of everything through which the organism lives there under favorable conditions. Alright, so talking about the first term that comes under habitat is the climate. So climate includes temperature, moisture content, resources are the major factors which interact with the organisms and determine the nature of habitat and ecosystem. And under climate we have another term which is the microclimate. So microclimate is the climate in a small habitat, which can be example as such climate below tree trunk, climate in soil, and many other small regions. Alright, so it has specific temperature, humidity, and light intensity. Alright, so we have climate, we have microclimate under habitat. So here we have another piece of resource, that is the habitat provides the animal and plants with food, water, space, and shelter. Alright, this is the prime point, that is the source of habitat. So the place and areas occupied by the entire community that includes some total of atmosphere and soil factors that we just read. So it has, as we just know, the climate consists of temperature, moisture, and resources which interact with each other and determine the nature of the resource. And all organisms have adaptations to survive in a particular habitat. Alright, so definitely organisms have to survive whether it be favorable or unfavorable. So they have to survive in such a way so that they make the climate or whatever the habitat is in their own way, in their own favorable matter, so that they can live peacefully. So we just talked about microclimates as well. Microclimates is the climate in the small area, a small habitat, which can be climate below tree trunk, and it has specific temperature, humidity, and light intensity. So habitats are different and have different characteristics. Alright, so it can be temperature difference, it can have difference in soil, sunlight, and water. So there are 4 different types of habitat that we can broadly divide. Alright, so 4 different categories of habitat are terrestrial habitat, freshwater habitat, marine habitat, and estuarine habitat. So we are going to discuss all of these 4 in detail. So let's get it. So talking about the terrestrial habitat. So it's the most variable in terms of both time and geography. This is the picture, just a demo picture, casual picture of a terrestrial habitat. Alright. So the factors affecting it are soil, climate, resources, geographical features. Definitely these 4 factors are pretty much common and they are dependable factors on which any of the habitat survives on. Alright, so the terrestrial ecosystem comprises of 28% of the entire world's ecosystem. 28% is a huge number as of the entire world ecosystem. So 28% of the world's ecosystem is the terrestrial habitat, and 6 primary terrestrial ecosystem exists. So there are 6 different types of terrestrial habitat, which are tundra, taiga, temperate, deciduous forest, tropical forest, grassland, and desert. And water is definitely an important factor in every sort of habitat. So water is not something that we think is in abundance, but it is not. So sunlight and gases are available in abundance. Alright, so these are some of the natural sources that are available to us. So talking about terrestrial plants, so there are some of the plants that are observed in these forests are Hydrophytes, which grow on swampy marshland habitat. We have Mesophytes, which grow on wet habitat. We have Xerophytes, which grow on dry and arid lands. We have Epiphytes, which live on trees such as orchids, bromeliads, mosses, and lichens. We have Lithophytic. Lithophytics are living in or on rocks. So this is some sort of a graph that we have for all the forests under terrestrial habitat, which indicates all of the average temperature and annual precipitation. Alright, so all of the temperature and the precipitation is denoted by this. So this peak shows that the tropical rainforest receives a huge amount of precipitation. So precipitation we have in the x-axis and y. sorry, the y-axis we have the precipitation and the x-axis is denoted by temperature. So the peak denotes that tropical rainforest is high, it receives high amount of rainfall, and definitely it is also very hot because we have the gradations here, like it shows 30 here. So 30 is pretty much high, as we know. It's just similar to a desert, as you can find here, which receives very little rainfall, or in a region of scanty rainfall. Definitely deserts are known for it, and temperatures are sky high, as you can see. And tundra region is the bottom or the narrowest point that we have here, which is the coldest and receives almost rainfall similar to a desert. All right, so moving on with this, so we have some of the four important types of ecosystems under terrestrial habitats, which are the forests. So here we have the picture for forest as well. We have deserts. Here we have the desert picture. We have the grassland, which is the savanna, and the Arctic or the Antarctic region, which comprises of all of the frozen regions. So this is the present day biomass. As you can see, the entire terrestrial habitat distributed in our earth, as you can see. So entirely we can see we have the tropical rainforests separated here and here. Everywhere we are present. We have grassland, we have deserts, we have temperate deciduous forests, we have taiga, and on the towards the pole, we have towards the end, we have the tundra region where the Antarctica and all of the countries are present. And some of the regions we have desert, which receives huge amount of sunlight, or receives high temperatures and very less rainfall. And some of the regions are scrub forests as well, and we have tropical rainforests, obviously. So these are some of the distributions that we have in the present day. With this, so we have three major geographical regions. All right, so this is the world map, as you can see. So talking about the tropical forests. All right, so the first terrestrial habitat, we have the tropical forest. So three major geographical regions that we have, so which are denoted by, so the green regions are the tropical forest. All right, so there are pretty much of good amount of tropical forest regions. So in America we have, so this is the part, American part, which is the Amazon River Basin. We have in Africa, which is this, which is the Zaire Basin, small regions of Western Africa, and then we have in Asia. So the Asia we have mainly comprises of regions in India, so which has west coast of India, Assam, and all of the regions. We also have it in Australia, Queensland, and New Guinea. Moving on with this, so talking about some of the features of the first forest of terrestrial habitat, which is a tropical forest. All right, so it has temperatures between 20 to 25, and it generally remains warm and does not the temperature does not drop too much. Also, it receives good amount of rainfall, as you can see, 2000 to 10,000 millimeters of rain per year, and it has good amount of humidity, as you can see, around 80% humidity. It has types of vegetation such as large trees up to 40 feet, having the most diverse trees than any other biome. All right, we have the tropical rainforest as well, which covers less than 6% of Earth's land surface. We have which produce more than 40% of Earth's oxygen. 40% of Earth's oxygen. It contains more than half of all the world's plants and animals. So these are some of the important facts that we have that may come in your MCQ or descriptive type questions. So some of the important points, it covers 6% of the Earth's entire land, and it provides room to 40% of world's oxygen, or the Earth's oxygen contains more than half of all the world's plants and animals. We have 1/4 of all the medicines coming from rainforest plants, and scientists believe that more than 1400 tropical plants thought to be potential cures of cancer. Definitely this is a very huge plus point. So these provide home or curation or services to cancer treatment. So next we have the temperate forest. So before going on temperate forests, like I would like to discuss in the next video in an elaborate way. So let's just keep this video till here and stay tuned for more, and I'll be very soon back with another video in which we'll discuss from the temperate forests. So stay tuned, and thank you for watching this video.